Yes, sir.
Okay, it's quite big deal, yeah. Okay, so today we will talk about the wireless LAN, which is WLAN. Okay, wireless LAN. So wireless LAN is actually is an extended of wired LAN. So we have a wire. Okay, this is the first one. Okay, local LAN network. The second one is wireless LAN. Okay, the wireless LAN is actually is like extendings of the wired LAN, because if we are using wire, so the problem is we need to get the wires and make sure that the clients or the users or the station or any kind of the user's machine or the client need to connect to the wire. Okay, so in terms of flexibility, in terms of what we call it, easiness, the wire is not easy because you cannot connect to the networks unless you have the wire. But after that, we will have a wireless LAN. Okay, wireless LAN to make sure that you are able to connect to the networks. Okay, so the access point here. But AP usually have a cable, okay, a wire things to the switch. So at the end, there's still a cable. Okay, in some point of view, cables connection is still the best. Okay, in terms of performance, in terms of stability, in terms of security, and so on, the cable is still the best compared to the wireless. But in the point of view as users, okay, that want to connect to the networks, wireless is what call it is comfortable, okay, easier compared to the wire. Okay, but this is the things, okay, the most important things. Okay, because we will talk about the wireless, so we will talk about so many things, okay, especially related to the electromagnetic wave, yeah? Okay, wave. So you already learned, except in the okay, you already learned in the high school. Okay, we have a wave like this one, isn't it? Wave. Okay. Wave is usually drawn in the sinusoidal parts. Okay, so there are several terms that we need to reconsider. The first one is in the wave there will be a amplitude. Amplitude is the power. Okay, the power that brings or sent by the waves. So this is, we call it an amplitude. Okay, so usually we measure it in volt. Okay, so this is the amplitude. The higher the volt is mean the higher the amplitude. Okay, so this is amplitude, and the amplitude usually will be changing based on time. So in here we have a time. So the what call it, the wave is traveling in the space, okay, through the time. Okay, so for example here in the t is equal to 0. Okay, the power is 0. Okay, but after that the power will be will be uh will be higher. Okay, and then sometimes go to minus. So it is like a sinusoidals in the alternating current. It's like an AC. Okay, AC. You know about the electricity is an AC and DC. Okay, so AC and DC. So is DC is like this one. Only doesn't have any sinusoidal part. Okay, only have a like a straight part with the number of, for example, like the volt. Okay, so this amplitude. Okay, so the higher the power. Okay, the higher the power. So okay, between that, the stronger the signal. Okay, so if you go to the, you see here, this is a signal meter, isn't it, for double wireless LAN. So if you get full like this one, it means that you get a full powers, okay, connection between your access point to your computer. So when there is an access point or Wi-Fi routers, it will send you a signal, okay, with certain number of power. It's like a radio. When you heard any radio, isn't it? Okay, so if your position is near to the transmitter, so you will get a very clear sound, very good quality sounds and everything. But if you're getting farther from the transmitter, so the quality will be low. Because of what? Because when the wave is traveling, okay, the power will be reduced based on the distance. Okay, based on the distance. So this one we call it amplitude. Okay. The other way is, another thing is, we will talk about the frequency. We'll talk about the frequency. What is frequency? Frequency is a number of cycle. So one cycle is like this one. It's what we call it, one cycle of wave. So one cycle is consists of one hills and one valley. Okay, so if you started from here, so one cycle will be this one cycle. So the number of cycle in a current amount of time is called frequency. So for example, in here, there is 2 cycle. Usually the frequency is the time, okay, is measured in 1 second. Okay. So how many cycle in 1 second? We call it hertz. Hertz. Tak silap ya? Kalau silap minta maaf. Udah lupa tak tulis nih. Dulu belajar masa undergrad. Udah berapa puluh tahun ya. Okay, so hertz, this one is hertz. The frequency is 1 cycle. Okay, how many cycles in 1 second? We call it in hertz. So if you have 4 cycle, for example here, if here is 1 second, in this example, so the frequency of this wave is only 2 hertz. If you hear, for example, like a radio, okay, with the frequency is 88.10 megahertz, can you imagine how many cycles were there in 1 second? This is only in 1 second. That's why the wave sometimes you can see it here. Oh, what's this one? Okay, or there is a wave like this one. What is? Okay, so you can see here, you have this kind of graphics. Okay, so actually we can see that the wave in the device, we call it oscillator. An oscillator is oscillating. Oscillator is how many time of repeating some things. Okay, so if the in the oscillators, if we see the wave is too dense like this one, so it means that this frequency is high, because in the same amount of time there are so many cycle. But if you this one, so this one is the frequency is lower. Okay, there will be sometimes there is a wave that have the same amplitude but different frequency, or sometimes there is a different frequency, have a same frequency but different amplitude. So it's two different things. Okay, so amplitude is the powers of what call it, the power of energy, okay, that sent from the transmitters, okay, to the receivers. will call it amplitude. The frequency is the number of cycles in 1 second, and the frequency usually calculated in hertz. Okay. So in the good, okay, example like a wireless devices, okay, we are allowed to change the amplitude, okay, or we can allow to change the frequency. Okay, so this is the most important things. Okay, because we are sharing the same space, okay, the same air. Okay, we will traveling all the waves through the air, isn't it? And everybody want to use this air, okay, to use this air to send their own their we'll call it their own works on their own everything. So not only wireless but can be for the cell phone and everything. So there is a regulations. There is a regulations how to use this this space, the rings of frequency. So that's why in here, okay, wireless, okay, wireless usually they use two frequencies, which is 2.4 gigahertz and 5 gigahertz. Okay, this is the radio frequency, 5 gigahertz and 2.4 gigahertz. Okay, 2.4 gigahertz. Okay, 2.4 gigahertz will have frequency is the frequency is equal to 1 per lambda. Lambda is wavelength. So if the frequency is low, so the lambda will be higher. So the wavelength will be bigger. Okay. If the frequency is high, the lambda, the wavelength will be lower. That's why 2.4 gigahertz frequency, actually it is, we call it, better in stability and penetrating the objects. For example, you have a access point in this room, and there is a wall and everything, and then this is the computer in here. If the AP working in 2.4 gigahertz, okay, actually it is better penetrating the wall because of the wavelength is higher. So if why it is that, for example, like here, there is some objects, okay, with what like the deep, or okay, it's 1 centimeter, for example, and you are having a frequency wave with the wavelength is 2 cm, so you are able to, okay, wavelength is 2 cm, so you will be able to penetrate easily. Okay, but if you have a wavelength from 1.50 cm, so this is less, this is an internet. So the wave is like this one is already 1 cycle, so usually it will not be able to penetrate good. So sometimes it's bounce back, okay, by the objects. Okay, so this is the characteristic. So that's why if you want to get the strongest, again, the strongest penetration testing or the strongest signals, okay, if your distance between your stations and the AP is longer, so better use 2.4 gigahertz. Okay, but the problem is 2.4 gigahertz is not only associated for wireless LAN. Okay, not only so many equipment, okay, that are using the frequency 2.4 gigahertz, but maybe the exact frequency is not 2.4 but 2.4 point something and everything. Okay, so for example, like this one, you see this one, this is my mouse. Okay, mouse is using wireless. Okay, and this is the dongle that I need to put on inserted into the USB port. Okay, both of them, okay, this one is also working in 2.4 gigahertz. Okay, fortunately, okay, the power, the amplitude that sent by these devices is low. So the interference from these devices to the Wi-Fi signal is also low. Okay, but there are so many kind of devices that working on that one. So the regulators of the Wi-Fi are creating another frequency for the Wi-Fi, which is 5 gigahertz. Okay, in terms of speed, 5 gigahertz is very, it has what call it, bigger bandwidth. So the bandwidth and the frequency is same lah. Frequency equal to bandwidth. Okay. So the higher the frequency, the higher the bandwidth. That's why you can see here. Okay. When we work the first time, before we have another things, for example, so another method to increase the frequency of 2.4, the data rates or the bandwidth of 2.4, so you can see the differences. And this is the original one. The Wi-Fi, the first time, is working in 2.4 gigahertz. It's only able to go for 2 megabit per second. But the first time for gigahertz is working on 55 megabit per second. Okay, it's the rate. Okay, after that, they try to create some new standard, new method, new inscriptions, new a lot of things to do. Okay, and then they are able to increase the 2.4 gigahertz into 11 megabit per second. And there is new technology, new chips, method, and everything. So they are able to increase for 2 gigabits into 54 megabit per second. And then currently we have more than 1 gig, okay, for wireless connection. Okay, so the about naming of the Wi-Fi. The Wi-Fi standard is created by the IEEE, and the code is 802.11. It is the same like Ethernet. Ethernet code, okay, is 802.3. Okay, any kind of technology that related to the Ethernet will be started with 802.3, and then after that they put like characters after that one. Okay, for example, like fast Ethernet is 0.3, fast Ethernet, and then become a 0.3 something. When connected to the fiber, it's 0.3 something. It's the same thing like is in IEEE Wi-Fi standard, it's 0.11. This is the first standard. And then they have an A, B, G, okay, everything's until we have currently AX. Okay, so AX is, I think we call it a Wi-Fi 6. Okay, Wi-Fi 6. This is the latest one. Okay, here there is something. Yeah. So Wi-Fi 1, 2, 3, 4, 5. Okay, what is Wi-Fi? Why we are using Wi-Fi? Wi-Fi is the name of alliance. Okay, alliances or organizations that give standardizations to the wireless devices. Okay, so actually the names, the standard name is 802.11, but because of the some standardization provided by Wi-Fi, and Wi-Fi have a logo Wi-Fi with a black and white, isn't it? So everybody see this Wi-Fi. So that's why they call the wireless technology, we call it Wi-Fi. But actually the wireless technology is not only the Wi-Fi. Okay, so Wi-Fi is the name of the standard, but yeah, because I already knows about the Wi-Fi, so you just follow that this is Wi-Fi 1, 2, 3, and everything. So any kind of devices for the wireless connections, okay, must be standardized or compliance with the regulation set by the Wi-Fi, and must be tested by the Wi-Fi alliances. That's why all the devices, if you bought any wireless router and everything, or wireless LAN controller in the back side, on the downside, you will see able to see the logo of Wi-Fi. Okay, if this device is certified for Wi-Fi 6, so it will come up with the Wi-Fi 6 logo. Let's have it here. Wi-Fi. This is why, okay, Wi-Fi and everything. Okay, so it's call it actually it's come up from the Wi-Fi alliance. Okay, it is an alliances and everything. So let's say, for example, Wi-Fi certified certificates. Okay, Wi-Fi certified. If you have found some devices and doesn't have any this kind of certified logo, so don't buy it. Okay. Okay. So this is actually the standard of IEEE. What you should do in here, just memorizing, and the radio frequency and also the data rate. Okay, some of them they have it. Okay, so it's a radio frequency. So the radio frequency, actually, radio frequency is has this kind of range. Okay, and light. Okay, light is in physics can be described as the first one as a frequency wave. Okay, radio frequency RF. The second one is as a photon. So this is the what call it the specialty of light. Okay, so when you talk about light that we can see, actually it's only in this range. This is what we call it visible light. Okay, visible light. But there are so many frequencies that we cannot see. For example, like X-rays, gamma ray, infrared, radio wave, and everything. Okay, but nowadays we are able to create like a camera that able to captures the infrared and also capture the X-ray. So if you go for to scan your bones or any kind of USG for somebody who are pregnant and everything, they use like this X-ray. Okay, and there's some power. Infrared usually for heat, isn't it? So you can measure the heat by using this infrared and so on. So radio frequency is working in this part. Okay, some of the infrared is we use for the remote control and everything. So this is the range that we are using. The radio frequency we are using is in this part. Okay, and you can see the frequency actually is lower compared to the eye. So our frequency, so uh, uh, give us a limit our eyes. Okay, so I'm able to see any frequency within this range. Okay, so if you're mutated or something, okay, so maybe your eyes able to see on the infrared regions and everything. So there will be some different things. You'll be able to see the heat dissipating from anyone's bodies, from the trees and everything. You will completely see the different things, okay, if you are able to see in the infrared regions. So the frequency, radio frequency Wi-Fi is working in this part, including the radio, including televisions, microwave, and everything. And some of the organizations they already creating the rule that the microwave should use this frequency, the radio should use this frequency to that frequency, and so on. Okay, the radio usually in megahertz, isn't it? Like FM is usually in the megahertz. If you are using AM, is in lower, usually in kilohertz. Okay, but Wi-Fi is already in gigahertz in here. In our light is terahertz. Is our eyes is capturing any kind of radio frequency in the terahertz frequencies. So let's see here. What is the component for wireless LAN? Okay, wireless LAN. Okay, so let's go to another things before we go here related to frequency. Okay, so this one, channel selection. Okay, so in the 2.4 gigahertz frequency, okay, they're creating a channel. Okay, if I'm not mistaken, they have 14 channels. Okay, but in here they only show in 11 channels. Okay, one channel have what we call it, bandwidth is 22 megahertz. Okay, so let's say for example, this is channel 1 is starting from when 2.4 something, okay, 2.4 something gigahertz. Okay, let's say for example here, let's say 200, okay, until 24022, okay, because it's 22 megahertz. After that, they will put another we call it external around 5 megahertz. So in here will be 2405, okay, and then the range of the channels will be 2425 because it's be 22 megahertz. This is the rule, okay. You can see here. So we can see here channel 1 and channel 2 is overlapping almost a half, more than half. Channel 1 and channel 3 is are overlapping almost in a half part. So you can see here channel 1 and channel 2, there is a overlapping in this area. Okay, this area. Okay, channel 1 and channel 3 overlapping in this area. So almost half. So if you have some overlapping, so there will be an interference. Okay, this will be like an interference. So you will have this kind of experience, especially if you are using the like wireless microphones, okay, and wireless speakers sometimes. And if there is somebody who are near to you are using the same devices and using the same channel or we call it nearby channel, okay, so your voice will be interferencing. So sometimes your voice will able to heard in their speakers, and the other speakers, the other presenters' voice can be heard in your class speakers. So that's why this is the reason actually why we are using the we call it still using the cable in our university or any kind of occasions because the cable doesn't have interference. So the best quality, most of the singer they usually have a cable, isn't it? Okay. If they won't use the wireless, okay, they need to make sure that there is no interferences or on the mic, especially for the artist who sings on the stage and everything. Okay, so that's why in here, when you are selecting the channel for your Wi-Fi, make sure that your channel is not interfering in one another. So, for example, here you can see here the channel number 1 doesn't interference with channel number 6, okay, and channel number 6 doesn't interfere with channel number 11. If you are working in the 2.4 gigahertz, make sure that you put it in channel 1, channel 6 on channel 11. What is about this one? Because of when we put an access point, okay, access point only able to cover several meters, okay, it's depend on the powers, okay, several 10 meters or 20 meters, okay, but we want to cover it the whole, for example, like 1 kilometer times 1 kilometers, for example, so you need to put a lot of access point, okay. So from one access point with another access point, you need to make sure that all the settings are not overlapping, so to reduce the interference. So for example, there is an access point in this area, and there is another access point in this area, and there is another point in this area. So make sure that access point number 1, number 2, okay, doesn't interfere with each other. So for example, you put here channel number 1 and you put channel number 3 in here. So there will be 50% power is interferences. The frequency will be interferences. That's why in this rule, okay, for 2.4 gigahertz, make sure that your frequency are doesn't overlapping, so they don't interferences. So we use the rule 1, 6, and 11. You can see here 1, 6, and 11. Okay, they will not interfere each other. 1, 6, and 11. But in here you still have some overlapping coverage. So if somebody are currently connected to your Wi-Fi in here and then it's moving through corridors and everything, through streets in your organizations. Okay, when they go to this part, okay, they already change into channel number 6 seamlessly. Sometimes we don't realize that actually we are changing the access point. Okay, changing the access point. And so if you move here, actually you are not connecting anymore to this access point number 1. Okay, no, but you're already connecting to access point number 3 when you move it. So make sure that any access point doesn't interlap, doesn't interference, do any interference, so we must do a channel selection. So can you imagine? So actually the wireless technology is very complex compared to the wire. Okay, but because of the conveniency, so they improve a lot in this part. Okay, so this one is for 5 gigahertz. Okay, for non-overlapping channel, you use 36, 48, and 60. And you can see, okay, you can see the differences is 20 megahertz per channel. In the 2.4 is only 5 megahertz, this is 20 megahertz. So you can see it's very good. And the way of their what call it technique for channel saturations, okay, are different. Okay, so the SSS usually used for 2.4 gigahertz, so it's like this one. Okay, but after that, if you go for the next one, we call it orthogonal frequency division multiplexing. So this is a new techniques how to improve the quality, to improve the bandwidth of the Wi-Fi. So you can see here, it's quite different, isn't it? The shape is quite different compared to this one, isn't it? It's quite different. Okay, so this is why when you select why 36, 40, and 60, and 1, 6, and 11, everything is because of the frequency range, radio frequency range in this part. So make sure hafal aja lah. Please remember, if you want to go for 2.4, that is the question rated 2.4 gigahertz. So 1, 6, 11. If there is 5 gigahertz, usually 36, 46, and 60. So this is the most important things over there. Okay.
Sir,
So you can, yes.
I have a question. If using some kind of channel 1 or 6 and 11, there is a limit of user. If everybody use the channel 1 and 6 and 11, where when people use channel 2 or 3 or something.
Okay. In this one is if you are personally using your Wi-Fi routers at your home, okay, you can select any kind of channel. You can select any kind of channel. It doesn't matter. Okay. Because it's not it will not interference except if your home is near with your other neighbors. For example, like if you are living in the apartment, for example, you're living in the apartment, okay, so maybe your channel will be interference with your neighbors in front of you, in the up, okay, on the upper side of you, and then in the down side of you of your house, okay. So it can be interferences, but so actually, if you are living a single and everything, so you can use any channel. Okay, you can use any channel. It doesn't matter. Okay, or if something like this one, I don't want to use 1, 6, and 11 for example. Okay, the purpose why we're using 1, 6, or 11 is because if you want to operate, okay, some certain area, okay, very big area, and you put so many access point, okay, so many wireless devices, we call it access point. So if you are using so many access point to cover a very big area, so you need to avoid the interference. So you need to select the correct channel. Okay, 1, 6, and 11, it is the best practice. But also you can use, for example, you can use channel 2, okay, and channel 2 will be going like this one, isn't it? Up to this one. And then the next channel can use 3, 4, or 5, or 6, but maybe you use number 7 because 7 is in this part, okay, and 2 is in this part. So you can use that one. 2, 7, okay, and 12. You can use it. Yeah. But usually the best practice non-overlapping channel is 1, 6, and 11. Okay, it's answering your questions?
Yes, sir. In addition, I have the question. How do we know that our neighbor use what channel so
We
that
cannot know.
we
We
cannot?
don't know. Except you have like devices to captures the frequencies range within your area. Okay, you don't know, but
Okay.
sometimes, okay, if uh for example, like you think that you use some channel and then you feeling that your performance is not good, for example, your performance is not good, so it means there is some indication maybe your frequency is your channel is interference with another channel. Okay, so you can try to change your channel into different things, different channel. So we cannot detect what is the channel used by our neighbors except you go to the routers, okay, of your neighbors, or you have like a frequency detectors devices that to read all the frequency uh, that come to in your space lah. So for this one, okay.
Okay,
Um,
sir.
this is our out of our scope for that one. But I want you to know that this is the facing the challenges that we face when we are implementing the wireless. Okay. So okay. So this one is for the things. So that's why when we deploy, for example, we deploy the wireless LAN for so many kind of area, for example. So you need to make sure, for example, I'm using this access point on the X spot and everything. So and then you considering that this is the range of the access point frequency, and then there are some overlapping area, isn't it, in here? So make sure that you are using the different frequency that doesn't overlap, non-overlap frequencies or non-overlap channel. So in the 2.4 is 1611. In the 5 gigahertz, usually use this one. Okay, 36, 46, 60. Okay, or any kind that have some kind of. You can select actually 64, 148, as long as it doesn't overlap. For example, here 56 doesn't overlap with 48, but 40 doesn't overlap with 52. Okay, so even though we said that 5 gigahertz actually 5 gigahertz, but it's not exactly 5 gigahertz. Okay, for example, like channel 36 actually is the center is 5.180 gigahertz. It is on the center, but actually the range starting from 5150 until something here, f2 something here around this area. So we will have a bigger channel. So if we have a bigger channel, bigger bandwidth in here, bigger range, so we have a bigger bandwidth. That's why 5 gigahertz actually it is a good things, okay, to have a very high frequency, a very high bandwidth, or very high speed. Okay. Let's go back to the first part. Masih banyak lagi yang kita buat ya. Okay, so let's go to the component here. So the component for wireless, the first one is wireless network interface card. Okay, so this is the example of wireless network interface card. But mostly of the laptop already have this wireless implemented or embedded in your system. But if you have any kind of like desktop and everything doesn't have any Wi-Fi embedded inside of it, so you can use this dongle. Okay, this dongle. I think this is TP-Link, and but we have another antenna to make sure that able to capture better radio frequencies. Okay, when using the wireless, okay, wireless NIC, you must connect to, we call it the access point. Okay, access point, and the access point usually will connect it to the switch. Switch will connect it to the routers. Okay, this is the best practice in any organization, in any kind of organization. But in our house, in our home, we already combine this access point, switch, and routers into one devices. We call it wireless routers. Okay, so that's why when at the home or in the small office, home office, so you don't use the access point. Okay, but you also use the you are already using the wireless home router, and this wireless home router actually has a access point in here to connect from this wireless NIC into the cable network. Okay, but inside of it also there is a switch, okay, and also provide the gateway to the ISP through the routers, okay, by using the router. So these three components actually already come into this home wireless routers. Okay, some of them, okay, previously when we still use ADSL, apa ya nama dia, stream mixing. Okay, so there is, we call it, and plus in here is a modem. Okay, modem to convert the signal from the computers into the signal of the telephone. Okay, that will carry your data to the ISP. Okay, but nowadays most of the devices, okay, already changed into fibers, isn't it? Or they already changed into fiber. So the modem actually sometimes is outside this wireless. Okay, there is a modem also for the Wi-Fi, for the fibers. Okay, this is the component. So how it is here? So usually all the devices, any kind of devices with IC will connect to the AP. Okay, connect with the AP. So there are type of AP categories. The first one is, we call it autonomous AP, because it's autonomous AP. So all the configuration is in this access point, the SSID, the password, the security, the authentication, and the integrity. Everything are in the anonymous AP. So our home, okay, our house and everything is mostly using this. We call it an autonomous AP. But the problem with autonomous SP is in configurations and management. If you have a very small, for example, small organization, for example, using 10 or 20 AP, it is still reasonable for you to use autonomous AP. Because of what? Because if you are using autonomous AP, if you want to change some things, okay, so you need to change all the AP. So changing the setting through all the AP, it is very time consuming. Okay, will need a lot of person to do it, especially if you are a very big company. So maybe you have 1,000 access point in your organizations. Can you imagine, isn't it? That's why in the UNP itself, we have a very big campus. So the access point only, the wireless connections only available nearby the buildings. Okay. Sometimes they put also only just inside the building. If you go, for example, 10 meters out from the buildings, you already doesn't receive any signal. Okay. So if you want to connect outside the building, so make sure that you are less than 10 meters from the buildings in the UMP. So they already designed like that one. They still haven't have any call it a plan to create the whole UMP campus able to be accessed by Wi-Fi. But some of the campus outside in the outside of UMP, for example, in the foreign country, any student able to connect to the Wi-Fi in the campus, whether we are in the field whether they are in the park. So it's different on this one. So if you are a very big organization, you cannot use the autonomous AP because you have so many AP. So in here, you use with control-based AP. So your AP, okay, you will buy an AP. We call it as lightweight AP, okay, access control, access point, okay, and then we'll control all these lightweight AP yang jumlah dia itu mungkin 100 or thousands and everything by using wireless LAN controller. Okay, wireless LAN controller. This is what we call it the design of IP categories. So there are several things that differences between the wireless when you are using autonomous AP and when you are using the wireless LAN controller. There are quite different things, methods, and everything. I will describe it to you here because I don't have the slide in here. Okay, so autonomous AP actually is very good things for the small things. Okay, autonomous AP, but control based by using the lightweight LWAP, okay, lightweight AP, and then WLC wireless control is good for very big organizations. So let's say, for example, how we implement the autonomous AP, for example. When we implement the autonomous AP, examples, you have a Wi-Fi here, AP here, AP1, and then there is an AP2 here. Okay, AP1 and AP2. Okay, AP1 is, for example, working for can be there is a two like a VLAN, yeah, VLAN 10 and also VLAN 20 in here. Okay. So usually it is connected to the switch, and then this is the access layers, isn't it? So connected to the switch on the distribution layers. I hope that you already know about the distribution layer, and then go to the core layer, core distribution access. So in here, when you do the access autonomous AP, okay, autonomous AP, you must set all here is trunk. And so on. In trunk mode. What you call it? The purpose is to be able to carry any data, okay, from one VLAN into another VLAN. So, for example, like here, there is a two computer, PC1 and PC2. Okay, that they are from PC1 is LAN 10, PC2 is LAN 20. When they are connected to the same AP, so the packet will go to the AP from PC1 and go to the PC2. That's how it works. Okay, but what happens if PC1 from let's say this is PC1 in here is also 1010. Okay, what about if they want to go to the PC3 here? Okay, and this is VLAN is different VLAN. So the packet will go here and go to that part, go to the core. Routing process is in here, okay, and go back here, and then go back to the RAM, go back to AP1, and then go to this. So this is how the traffic actually will work in the autonomous AP. Okay. The other problem is if we have a trunk here, so if there is any broadcast message, so the broadcast message will go all over the network. Is another thing. So that's, but if we are using WLC, okay, you are put the WLC here. Okay, WLC here. And then what happened here? WLC and the light wave access point, there will be like a tunneling. Okay, tunneling things. Okay, tunneling things here. I will talk to you about the name of tunneling later on. Okay, and if you want to send from PC1 into PC3, you don't have to use the trunk. In here, you can use what we call it access networks. Okay, you don't have to use trunk. So from PC1, the packet will go to the channel and go to the wireless controller, and from the wireless it will decide it and go to the PC2. So it will not go to the core, okay, except there is a routing from something here. So when we are using WLC, actually it is have a better performance actually, because we don't need to set all the connection in trunk. Okay, only several connection in trunk, so most of them are still in the access. So if there is any broadcast message, so it will not affect the whole network. And in terms of security, is also secure compared to using the trunk. So I don't know whether you are get it or not, because it actually is very complex thing. So I hope that you understand the differences between autonomous and okay. So related to the antenna, there will be a omnidirectional. Omni is all the power are spread it 360 degrees. Okay. So in directional, it means that if directional, it's their design, the antenna is going only to some certain part. So usually this kind of directional is used for long range, sending. For example, like from one tower of our cell phone into another tower of cell phone. Okay, they will create connections. They usually use this directional one. Or the other one is using multiple input, multiple output. Okay, this multiple input, multiple output usually for increasing the bandwidth. Okay, there can be mostly they are omnidirectional, but they won't increase the bandwidth. Okay, so what is the modes of wireless? Can be ad hoc. Ad hoc is point to point. Okay, infrastructure is this one, using the autonomous AP or using the wireless LAN controllers is the mode for the wireless. And also about the tethering. Tethering is, yes, it's become like routers, okay, to connect to another devices. Okay, so nowadays, okay, mostly, okay, we want to extend the range of connections. Okay, we put the another AP, okay, and then the AP is connected to the wire. Then we put another AP and connected to the wire. So we will have a very good range of spread, isn't it? But already we call it Wi-Fi technology, what we call it mesh technology. So what is mesh technology? Mesh technology is if you have a like your home, okay, and then your home is lack of a wired interconnectivity. So you can, for example, AP. That you have very big, yeah. You put AP here, you put AP here, you put AP here, for example. Because of lack of the connectivity, maybe you cannot create an AP in this part because there is no wire. But by using the mesh, actually, we have an AP here connected to the wire, okay. But we create like another AP, but all the AP are communicated by using wireless. So put AP here, wireless. So this is the new design of the wireless. We call it mesh. Okay. So for example, you have a very big house, for example. Okay, very big house, and then with maybe not only one stories, maybe 2 or 3 stories. Okay, and then the routers that connecting the internet is only in the first floor. Okay, kalau di luar negara tuh ada yang dia letak kat basement. Okay, the routers and everything, the connection letak kat basement. And then from the basement, they put access point. Okay, and then in the first floor, they create another access point and they're connecting by using mesh. They don't put any cable. Okay, so the access point in the first floor is connected to the access point in the basement. And then another access point will connect to the access point in the first floor and everything. So they're creating like a mesh. So everybody are able to connect. If you have 10, access point, maybe one access point able to connect to 4 or 5 another access point that have interference. So this is what call it mesh. So if you have ever heard a mesh wireless and everything, since no technology, so you are covering mesh. For example, currently like Unify or Times, okay, they offer, for example, one of the bundle with the mesh technology. So you will get the one routers, wireless routers, and several devices, maybe one or two mesh access point, like an extender for access point. So this is what call it a mesh. Okay, it's out of this one. Okay, in here, okay, for AP we call it basic service set. Okay, basic service set, basic service set. Okay, and they will broadcast the SSID in here. Basic SSID. So one SSID and another SSID, okay, can be organized or can be connected by using what we call it extended service set, like here. So, for example, you have SSID, for example, staff. Okay, in here also they have a staff SSID. Okay, they are able to um, do extended and with the same SSID through all of them. Okay, so related to the 80 to 11 frame structures, in here is you need to remember only all the functions. Okay, by default is almost the same as Ethernet. Okay, there will be a payload, there will be a headers, and there will be a frame check sequence. The differences is between the Ethernet is in the headers. The headers of the 802.11 is more complex. For example, here they have 4 addresses here, 4 addresses, and there will be a duration. There will be a duration or ID here. Okay, and will be a sequence control and everything. So what you should do here, you just remember what is the what call it uh, susunan dia tu ya. Okay, remember the after the frame control is duration and then address 1, 2, and 3, and 4, and everything. And then this is the field. You must know what is the function of the field. Okay, for example here, the address one is usually the final destination. Okay, the address one is the originals of source, origins of the source. This is the address. Okay, and address one is intermediate destinations. Okay, intermediate receiver. Okay, and then address four is intermediate sender. Intermediate receiver and sender is not the original source address and not the final destination address, but is in between, because from one access point can go to another access point, can go to another access point. So they have this kind of 4 addresses for these purposes. And we don't have this kind of 4 addresses in the Ethernet. We only have 2 addresses, the source and destination. Okay, and then a lot of things in here, including in the sequence control, there will be in the QoS. So if we put more deeper in here, there will be in the QoS, there will be some any kind of things. Okay, controlling the sequence and so on. And durations in here is also about the how many time that the slot will be used to send the packet. So the differences between Ethernet and and what call it and wireless is on the system. So Ethernet, okay, we use CSMA CD, isn't it? But in the wireless, okay, we use CSMA CA. CD is collision detection. The CA is collision avoidance. So in the wired connections, we try to detect the collisions, and if there is any collisions, so we will try to solve how to resend the packets. But in 802.11, we don't use the collision detections. We try to avoid the collisions. How to avoid the collisions? if somebody, there is a PC here, PC1, okay, want to send, okay, the package or the frame or the data and everything, the access points in here will decide. So I will send you duration from 10 milliseconds to transfer the file. Okay, whether it is finished or not finished, you have 10 milliseconds. And then I will give turn to another virus, another PC, and so on until this PC get a next turn. Okay, but because of it's very fast, so we don't realize that one instead. We didn't realize that one. So, and how they put these durations, it's in this part. So just please remember that one. This is CSMACA. Okay, half duplex and wireless LAN is half duplex, and a client cannot hear while it's sending, makes it impossible to detect collisions. Okay, that's why the wireless LAN is using the collision avoidance. Okay, so in here, so the wireless when wireless client when go to the AP, okay, what they do actually they try to probe the access point. Okay, is there any SSID, for example, like staff SSID or not? If there is, the probing is okay, so there will be a result. Okay, so there are two types of probing. The first one is active. The second one is passive. Passive is mean that this is the thing that we usually have. So the AP will broadcast the SSID. Okay, and the client will receive the broadcast. So that's why we are able to see wireless A, B, C, so many RSID because they are using the passive. But in some of the organization, for example, like in the hospital, like in the bank, or in the what call it, kilang, in the factory and everything, they don't use the passive because they don't want anybody knows about their wireless SSID. Okay, what they do actually, they will do the active one. Okay, so you will not see the SSID and everything, but the workers or the staff knows that there is this SSID and I can connect to that SSID as long as I know the SSID and know the username and password. So that's what call it an active one. So the first one is we probing here. Okay, probing. After they probe, okay, there is an SSID, and then the wireless client try to connect to this one. Okay, and this connects, so they do the second one is authentication. So in here, we need to use the password. So in our home, we use the password, we put the password, okay, when we try to connect to any kind of home wireless. So in this part is, we call it authentication. If the access point or wireless router receive this password and it is correct, so they are given notifications to connect with my wireless access point. But it doesn't mean that you able to access to the network. No. After they do that, they will do an association process. What is the association process? Association process is that this AP actually connected, this client connected to my AP. Okay, so I will give them a time. Okay, a slot to send the packet. Okay, so this is association. We call it this one. So actually there are three steps: this probing or discovering, and then authentication, and then association. So in order to achieve the successful wireless and everything, they must agree with the SSID, the password here, the network code. Okay. So if the AP is only able to do N, AC, and AX, so your mode in here must be N, AC, or AX. You cannot use the B and D wireless. Okay. And then the security mode. Okay, security mode and everything. You can use WP, WPA, WPA2. The newest is WPA3. It's in 2018. And then the channel setting, the frequency, and so on. Okay. So this is active or passive discovery. So we already here. Okay, so passive, the app is sending to the wireless client. Active is mean the wireless client is sending to the AP. This is a CHAPWAP. We are using the wireless LAN controller in here. Okay, so the wireless LAN and the AP will create what we call it management functions and sending data function by using a tunnel. We call it CHAPWAP. Okay, so the CHAPWAP, in the tunnel CHAPWAP, there are two type of tunnel. The first one is control, and the one is data. So the data usually using the UDP 5247 and control basing 5246. So wireless LAN controller is usually for controlling the AP. Okay, so if they send the signal control, they will use this port number. Okay, and I already told you the AP when they want to change, okay, from one AP to another AP, okay, to send the packet from one client in AP1 and the other client in the AP7. So they will send the data through the wireless and wireless LAN control, and the wireless control will go to the AP7. So this kind of data transfer is using the WAP data tunnel and will be sent to UDP 5247. Hafal ya nih? Okay. So they will create like this one, WAP. So I already told you that it's quite difference between mechanism of transferring data in the autonomous system and the WLC. This one. By using the WLC. So that WAP is stand for control and provisioning of wireless access point. Wireless access point, wireless LAN controller actually is the best method to maintain, to access your, collect your wireless things. Nowadays, actually, Cisco created cloud-based controller. Okay, what is the meaning this one? So this means that the product is, we call it Cisco Meraki. So the Cisco Meraki in the cloud, all the management's data will go to the Cisco Meraki. Okay, will go to the Cisco Meraki over there. So I don't want to change this one. Okay, so this is, we already channel management, we already talked about that one. Okay, related to the security, okay, there are a lot of things that we need to consider in the security because everybody are able to try to connect to the wireless. Okay, that's why we need to secure the wireless LAN by using the SSID cloaking, so we don't advertise the SSID, and then maybe we need to filtering the MAC address. Okay, and then we must go with the authentication method. In 2000, beginning of 2000s, okay, Japan starting have a package for DSL internet plus Wi-Fi. Okay, but they use open authentication by default, so everybody are able to access to the others Wi-Fi. So we can access to the our neighbors Wi-Fi because this open authentication. Okay, and there is no authorization and everything. So this is the first time when we are creating the wireless LAN. Okay, 802.11. We are using the open system authentications. There is no password required and everything. Okay, but after that we use the preset key. Okay, preset authentication. So and then we can have a WAP. Okay, a WPA1, WPA2, and WPA3 over here. Okay, this is one is the share authentication. So that's why WAP and everything, WPA, we must have a usually we have a password to connect to the access point. But authentication, open authentication system is still used by so many kind of organization. For example, you go to the Starbucks, for example, or you go to the LIA, International Airport, isn't it? So you are able to connect on the Wi-Fi in this international airport directly without using any username and password, isn't it? But after that, it's already authenticated with the access point, but it's you're not allowed to use the networks. So the association hasn't been given to you. So there are another layer of security there. You need to use username and password, or you need to register by user email and everything. So for to get 24 hours and everything, or you receive the code, the password from the Starbucks receive inside of it. So it's up to them how they will to do it. So to add the layers, security layers uh, for the open system authentication. So that's why the open system authentication is still available up to now. Okay, and there is also we can use the shared key authentication method in this one. So let's say go to the authentication method. So the first one is we call it WAP. WAP is using this reverse chips for the encryption. So when you do an authentication, so you send a user password, isn't it? So you don't want this password will be kept by another person. That's why when you do authentication, they will create an encryption. So they will agree with some encryptions. So WAP are using the RC4 authentications. Okay, but it is very low in terms of security. That's why please don't never ever set up by using WAP anymore. Even though in your home router there is still WAP, so but please don't use it. WAP, and then creating a WPA, okay, with are using the ticket, okay, using the ticket. The ticket actually is created to overcome the problem on WAP. So WPA using the encryption is ticket. So please remember this one. WAP using RC4, WPA using ticket. Okay, or it is better compared to that one. But also WPA, the algorithm and everything has been able to be hacked, so it's not secure anymore. That they created a WPA2, okay, with are using the IAS encryptions. IAS encryption is one. Okay, IAS encryption, and then currently there are a new one with WPA3. Okay, so if you bought the Wi-Fi, home router, and everything for the current years and everything, so make sure that they are able to support WPA3. Okay, kalau tak ada, memang harga dia selalu murah lah kalau tak ada WPA3. Okay, but WPA3 already become standard now. Okay, so if you have an old router, for example, old router, try to find the updated firmware. Okay, the firmware from the maker, and then update it, so you will get the WPA3. Okay, except your access point or your home router is very old. So if it's very old, I believe that the hardware will not support, because encryptions and everything require a certain hardware. Okay, certain hardware requirement to do that one. Okay, so WPA will use to call it PMF, protected management frames. Okay, but of course it able to use the AAS, able to use the everything. So if you are authenticating home in users, okay, you can use the personal one. Okay, by personal one, use a preset key. It's like we use every day. And the other one is enterprise. So enterprise, usually they will have a server or the username and password management. Okay, the first one is we call it radius, remote authentication dial-in user service. Okay, usually it's used for the old method. We call it dial-in. Is it? At that time, is radius was used by the SP to manage the dial-in users. Okay, and then in the enterprise, we use the standardization of 802.1x. Okay, this one is to give a controlling port. Okay, by using 021x. Okay, so you can control, you can set up the port of the switch. Okay, or okay, associated with certain VLANs or certain features or certain security development. One, yeah. Okay, and of course, when we select the authentication method, so you are able to select the encryption. So this one is here. So you can select, you're able to select the AES or TKIP. Okay, but please don't use TKIP anymore. Please use the AES. Okay. Okay, AES is one of the methods we call it CCMP. Okay, but if we go to the WPA3, if I'm mistaken, we have the here. The WPA3, we not use the CCMP anymore, we use CGMP. You can search in the internet. Okay. Okay, this is authentication. So if you go to this wireless and everything. So this is configurations. Because of we have a configures and verify on the wireless LAN. Okay, so what you should do here, you need to practice. Okay, configuration is using the GUI. So fortunately, packet tracer is able to do that one, to simulate that one. So there are several basic things in here that you need to do. For example, like login into web browsers. I can change the IP address for the HCP, change the username, SSID, and everything. Change the security mode and so on. Okay. So this is a basic one. So I will show you later on. Okay. Okay. So let's see here. And there is also another things like the controller by using the radius and everything for the enterprise and so on. So let's have I will give you the PK file so you can practice on your own. Okay, don't forget to sign your attendance, okay, in the chat box.
Sir,
Yes.
where can I get this slide?
I haven't sent it. Oh, I haven't sent it. Okay, so I will send it to you. Okay. Okay, I send it to you after the PK file. So I will open one of the PK file. There are two PK files, but okay, so we will go for the configures the wireless LAN networks, the 13.1.10. Okay. Okay, so I will go to doc here. Okay, in here there is a wireless routers. There is also an access point. There is also a client in here. So from the wireless router, so the routers, we will connect it to the internet. Okay, and the internet there is a cisco.pk file. Okay, so the wireless router. Okay, we can we can configure the wireless router through the CLI or through the graphical user interface. Graphical user interface usually based on the web application. Okay, so because of this wireless router doesn't have a CLI, so I will try to connect by using the GUI. Okay, but in the real world, maybe in the real world, so you will have a wireless router that can be configured by using the CLI. So in here, we need to connect the admin to wireless routers. Okay, we need to get the straight to cable. Okay, so and I will click on the fast Ethernet and click on the wireless LAN and choose any available port over there. So I will go to the straight. This one is straight through cable. Okay, and connected here and connected to, let's say, gigabit Ethernet 01. Okay, we will wait until it's become green, or we click on the fast forward. Okay, already become green. So in here is already connected through wires, and in the wireless router, especially they already creating the DHCP server. Okay, by default, including our router, isn't it? If you bought a new routers, wireless routers, and then you connected your laptop by using a cable, for example, so you already automatically will get the DHCP. So in here, I want, in order for admin to be able to access to the wireless routers, so I need the IP address. So I'm going to the desktop and go to, it seems still static. So that's why there is no IP address here. So I will click on the DHCP. So requesting it, and I get this IP address. Who gives this IP address? The wireless router, because inside the wireless router there will already activated the DHCP services. Okay, so after I get the IP address, so you can see here default gateway is 192.168.0.1. It means this is the wireless routers. The gateway is this one. Okay, so I can try to ping that gateway. IP configs. Okay, pings 192.168.0.1. Okay, so in this part, hey, is there anybody already did this activity before? Maybe during the network technologies, anybody did this one? Okay, so if not, we can try it by yourself. Okay, so and then I go to the admin, I go to the desktop, I go to the web browser. So go to the web browser, and I put the IP address of my default gateway, which is this wireless routers 192.168.0.1. Okay, and there will be a password, admin here. Use admin for both of them. Okay. So this is the graphical user interface of wireless router. Okay, wireless 3-band home routers, okay, of the Cisco. Okay, and you can see here, okay, under the network setup, okay, setup, okay, click, go to the setup. So you will have a DHCP here, isn't it? It's already enabled. Okay, and starting from 0.100 until 50. Okay, so the maximum will be 0.49. So that's why this is the reason why comment from here I get 100. Okay, because I'm the first person to connect to the DHCP servers. Okay, 192.168.0.1 admin. So in here, okay, we will go to the internet setup here. Okay, it should be able to connect to the Cisco PK, isn't it? Able to go to this one. But because of this not yet configured, okay, so we need to configure manually. You can see here the internet setup actually can be go for the DHCP, but I believe that this ISP here doesn't work for the DHCP automatically give to the client, so we need to make it a static IP. So we will put all the IP address that we got from the internet from the ISP. We put it here is 165, okay, and then 200, 225. Okay, subnet match is 255, 255, 55, and 252. 252. Then default gateway will be 209. Okay, all the information will be given by the ASP. Okay, kalau kita pergi Unify, nanti ada staff Unify datang, dapat kita, dia akan setupkan untuk kita. But if company usually it's depend on the price. Okay, if the price is including the setup, so they set up. But usually the company doesn't want the ISP person set up in their router, so they just need to require all the information given, and then they will set up by themselves. Okay. Okay, the center and everything. So we need to save the settings here. Okay, so you can see there. Okay, scroll down and okay. So make sure, okay, how to make sure that we are already connected to the what's it, to the internet. So if you have a requirement, close the admin windows and wait for the orange light. Okay, the orange light. Okay, so it's not connected. So wait for this one. Because of when we save setting, so usually the router will reset, will reboot. This is the basic thing. Okay, so that's why it requires timeout because the admin cannot go to the W routers over there. Okay, cool. Wait. Okay. Okay, 192.168.0.1. Okay, admin. Sorry. Admin. Okay, so everything already set up in here. So we can try to go to here and open for www.cisco.pk. Okay, so it's mean currently we are able to go here to the internet. Okay, so we finish this part. Okay, we will configure the wireless. Okay, so we open this one again. We will try to configure the wireless. Currently the wireless router already on, but maybe the wireless is not yet configured. So this is you must do when you bought a new wireless routers. Okay, set up for the ISP and then set up for the wireless things. So in here there is a wireless here. Okay, and we will use the 2.4 gigahertz. Okay, basic settings. Okay, 2.4 network mode. Okay, network name dari default kita jadi apa? A company. And the standard channel. Okay, I will change to channel number 6. Okay, number 6. Okay, auto channel ballot auto. Okay, so for this FTP, disable both of the 5 gigahertz. Okay, disable that one. For this activity, okay, kita disable. Okay, and then we save the setting. Okay, verify wireless basic settings, and then verify, click save, and then we go to the Pfizer security in here. We would like to use the WPA2 personal. Okay, and setting the AS and setting the password. So this is what we call it pre-shared key. Cisco 123 and then okay. The other one is disabled. So save the settings. Okay. Right. We go here, everything is okay. Go again here, everything is okay. So in here, after that, we are able to try to connect the client. Okay. So I will go for the laptop number 1. Okay, and then go to the desktop. Okay. And then click PC wireless here. Okay. Select the connect tab. Okay, try to go refresh to find there is a company. Okay. Put here. And then connect. Masukkan dia punya ini. Cisco 123. And then question mark. And then try to connect. Okay. You can see that the channel is number 6, isn't it? Okay, you are already successfully connected to this one. Okay, so we'll try to go to the desktop and try to go to the server. www.cisco.pka. Okay, so already able to do that one. So we go for the same thing here for the laptop number 2. Desktop PC wireless. Try to connect, refresh, try to find out what is the. Okay, we have a net company here. And then try to connect. Cisco 123. This one. So actually there are several things. So we put the same security and the same password. Okay, let's try to break this one to the www.cisco.pk. Hello, www.cisco.pk. Okay, connect wireless client to the access point. Okay, an access point is the device and everything, so we configure the access point. Okay, so in here, access point is like an extending part, okay, for the client to be able to go to the wireless to the wired connection. So the first thing, we need to have a cable between the wireless router and the AP. Okay, so we go to straight to here 40. We put it on any kind of this one. So make sure that one. Okay, we click on the AP, and there will be a config here. Okay, we can change the name and the interface. Okay, select port 1. Okay, and then put the SSID a company, and then select the WPSK. Okay, and then put the password. Okay, keep the IS. Okay, so after that, from laptop 3, we try to go here and the PC wireless. Next, we try to refresh. Okay, there will be a 2 A companies, but the A company that come from the routers, okay, wireless is actually channel 6. So we select the channel 1 because it's the IP. Okay, connect. Let's go 1, 2, 3, and connect. So it's already connected to that one. Okay. So there are so many things in here. For example, like change the password and so on. Okay. Instead of, let's say, kayak gitu ya, Cisco dot. Okay. Okay. So automatically it will receive the isn't it? Receive this. How it get the IP address? It's get it from the wireless router. Okay, all the DNS server and everything is also received from the routers. Okay, DNS server and so on. This DNS server. Oh sorry, satu. So you can see that one. Okay. Anybody asking any questions? Okay, so from here actually you can change the password. Okay. Hello, not responding. Terus siapa? 192.168.0.1 admin okay. You can go to the administration here. Okay, and the management you can change from admin into Cisco. Okay. Okay, we can save the settings. Okay. So now I'm using the new sorry, password is the user and still admin. Only the password is still. Okay. Okay. And then we can change the HCP, for example, setup. Okay. Okay, and then there will be a basic setup here. In the networks, you can change the IP. Okay, instead of 0.1, you put it 0.50. Okay, and so on. 50.1 is the router IP. Okay. Okay, over there. Okay, and then IP address assigned to IP is okay. Verify that still start with 100. Okay. So, okay, CB enables. Okay. So you can see here DNS. You can set up the DNS 209 directly to the DNS 165, and then apa nih 201 and 1. Okay. Save settings. Okay. So you can see here the start IP already not 0 anymore, only 50. Okay. And then you can go from here. Sorry. From command. So IP config release. What is the IP address? Oh, doesn't have any IP address here. Okay. Config renew. Why it cannot get the IP address? Okay, 50. Okay. Okay, I got 50. So this one is the things that we already changed. 102 and everything. So this is how we set up, configure the wireless. Any questions? So what is the recommended for the wireless infrastructure design of an organization? That's why it's organization, yes, not home. Okay. So what is your best answer in here? So what is the answer?
B.
B.
B. Okay, include at least 2 access point on non-overlapping channel to support balancing. Include at least 2 access point channel on non, at least 2. Okay, to support load balancing. We don't want to support the load balancing sometimes, yeah. Okay, so the answer actually the one is D. So load balancing is sometimes we don't use load balancing, but the first thing when we do the organization is coverage area. Okay, coverage area. So the coverage area is good things. Okay, but if the coverage area has some overlappings, okay, on off of it, so they will in the overlapping area they can do the load balancing. Okay. So what is the purpose of SSID?
Identify a WLAN.
Sorry. So let's go. So SSID, the purpose is to identify a VLAN. Differentiating traffic entering access point? No. Provide security? No. Okay. Identify an ideal access point on the VLAN? No. Access point, okay, maybe you can put any name on the access point, but SSID is for the purpose of the client, not for the purpose of access point. So the purpose of client to identify what kind of wireless LAN names that I can connect. Okay, so WPA2 PSK is configured it. Oh, tadi tak ada ya. PSK ini dalam 8 sampai 63 karakter ya. So, jawabannya dari 8 ya. Minimum one is 8. Nah, kalau yang ini nih. Intermittence, okay, intermittent itu adalah interferencing. Okay, so kira-kira agak mana? Which one is this one? The answer for this one. Intermittent is interferencing, experience interferencing connectivity. Kenapa E? Why E? Oh, dan D. 3 dengan 6. Ini bukan jawaban ya. Pertanyaannya lah, kenapa pilih jawaban itu? Why do you choose this one? What is the reason?
Sebab
2
dia
and 5.
overlap.
Sebab dia overlap. Itu yang jawaban yang mana nih? Which answer this one? A, B, C, or D? Yang E. Overlap. 2 dengan 5 pun overlap juga. 2 dengan apa? 2 dengan 5. Iya kan? Overlap. 2 5 tak overlap ya. 1 dengan 2 overlap. Yang C pun overlap juga. Nah, itulah. The same channel ya. Jawaban dia Abdul Muiz ya. Betul. For example like here. Jawaban 2 dengan 5. 2 dengan 5. Dia memang tak ada overlap sama sekali. Okay. So there will be no interferences. Okay. And then 3 dengan 6 pun sama. Ya kan? So 1 dengan 2, 1 and 2 overlap. But they are different channel, isn't it? 1 and 6. Even though they are overlapping, they will not, what call it, interference, do any interferencing. Yeah? There is no disturbance. Okay, but in here, zone 3 and 4, they are using the same channel, channel 11, isn't it? The same channel 11 in here. Okay, and then they have overlapping in here. So they will do an interferencing. Okay, this AP and there's another AP. So, okay. An engineer must configure a WLAN using the strongest encryptions type for WPA PSK, which ciphers fulfill the configuration requirement. No worries, Abdul Maiz. You can use chat. Okay, which answer this one? What is the answer for this one?
A, maybe A. A, yes.
Yes.
What about RC4? RC4 dipakai untuk mana?
WPA. Yang first one.
WPA, the first one. WPA first. Okay. So actually RC4 is for WAP. So this is WAP is not a hyper. Okay. This is authentication method, and WAP using the encryptions is RC4. Okay, WPA only. Okay, WPA only, not WPA2, not WPA3. WPA only is using encryption is TKIP. Okay, WPA2 able to use TKIP and able to use the AES. Okay, so A, B, C, and D. Rasanya VLAN ID tak ya? Ada yang jawab VLAN ID kan? VLAN ID kan untuk VLAN ya. There is nothing related to the wireless. Oke, agak jawaban dia mana? Oke, jawaban dia ada SSID. Oke. So, unique identifier that access point used to establish and maintain wireless connectivity to wireless network device. So, wireless network device ni seperti komputer kita, cell phone, our computer and everything is same. How to establish a connection to the access point? They usually we select the SSID. Oke. Oke, ini tadi saya mau terangkan ya. Jawabannya adalah client band select. So, another observes high usage on 2.4 channel and lower usage on 5. What must configure to allow client to professionally use 5 GHz access point? So in here, this is in the enterprise level. Okay. Siapa yang ada Unify kat rumah? Is there anybody who are using
Saya.
Unify? Okay.
Saya.
Ya, dekat Unify itu selalunya ada berapa SSID yang keluar daripada router? 2.
2.4 and 5 GHz.
2.5 and 2.4 and 5 GHz. So dekat router yang low budget router macam yang kita pakai dekat rumah nih. So 2.4 or 5 gigs, they are separated. They separated that one. Okay, they separated. So itu sebabnya dia ada 2 SSID itu. Sebab dia activate dua-dua sekali. Gitu. Sebetulnya kita boleh tukar tuh kalau you masuk dalam router, kita boleh tukar nama itu. Kita nak buang yang 2.4 macam itu kan. Boleh buang yang 5 GHz, 5 gigs and everything. So, kita boleh buang, boleh tukar pakai nama-nama lain lah. Yang kita hanya tahu bahwa dia frekuensi berapa. So, selalunya macam tuh kalau yang home. Tapi kalau yang syarikat nih, dia boleh assign satu SSID itu yang sama untuk 2.4 or 5 GHz. Boleh assign dua-dua yang sama. Kemudian kita boleh select client band select. Okay? Client band select. Untuk dia boleh client tuh dia boleh tersambung ke mana? 2.4 ke 5 GHz. Okay, untuk enterprise level lah ya. Gitu. Atau kalau yang Soho tapi yang dah medium, okay? The medium level atau intermediate level, so mungkin juga adalah facility itu. Tapi kalau dekat enterprise dia selalu adalah channel client band select. Jadi kita kalau nak sambung dekat SSID itu, SSID satu aja, satu SSID. Ketika nak sambung dia pilih 2.4 or 5. So itu disebut sebagai client band select. Oke. Kalau saya ya, kalau ada 2.4 atau 5 GHz, oke. If I'm go through the speed, so akan pilih 5. Tapi katakanlah 5 ini sinyal dia rendah, misalnya dia satu baris and everything. So saya akan pergi ke 2.4 to get the strongest connection. Nah, kecuali saya boleh pindah tempat, cari yang tempat yang lagi strong dia punya Wi-Fi connection. Okay. Which mode allowed access point to be managed by a Cisco wireless LAN controller? Jadi access point yang seperti apa yang dia boleh di manage by Cisco wireless LAN controller atau WLC?
Lightweight.
Lightweight ya. Kalau autonomous tadi tak boleh lah. Bridge, express tak ada. This is only several examples. Okay, so Dr. Sharul already give you the file, isn't it? Let me take it to you. Mana ya?
Sir, can I have the topic plan? Today we are teaching VLAN, and then next week what topic, and then that schedule we don't have, right?
Huh? The topic today only the wireless LAN. Okay.
The next one, how do we can find out, like the next upcoming week?
The next upcoming week. Okay.
Yeah.
Okay. So I thought they already given to you. I already got the topics that I need to send it to you. Okay. So let's check it. Okay, I will check it for you. Okay, what is the next topics? So the current topics we only cover wireless local area networks. Okay. Have you received the file from Dr. Shahrul? I saw the posting.
Which file, sir?
Sample Ccna question ya. Ada ya?
Yes, sir.
Yeah, so please try to open that one. Okay, and then try to understand what is the question over that that related to the wireless LAN. Okay, try to answer it. So we don't have much time. So actually, you need to read that sample questions. Okay, to find out what is the level that you will face, the question level that you will face during the exam, and then able to to benchmark yourself whether you already understand the topic or not. Okay, so I think this one. So let me forward it again here. So KPTPACE2. So try to understand why this is the answers. Okay, this is the most important thing, I think. Okay. Okay. I think that's all for wireless LAN. So the second scope packet tracers. Okay, you can try to do it by yourself. Okay, kalau tengok saja rasa senang ya. I will also give you the link on YouTube. Okay, if you find a difficulty, so you can click on this link of YouTube and try to follow. Okay, somebody already did this lab. Okay, and try to get what you call it the pictures, the figures. Okay, because in the topics, okay, in the exam topics or wireless, there is some configuration by using GUI. Let's go to the exam topics. Okay. Okay, for example, like there will be a WLC here. Okay, access point. Okay, there is also non-overlapping IP channels. Hilang. Sorry. SSID, RF, encryption. I already covered it for you, isn't it? Okay. Network access, for example, configure and this connectivity. Okay. Describe physical accelerator connection of LAN, AP, wireless trunk, LAGs. Describe AP and describe which one. Configure component of wireless LAN connected using GUI only, such as WLAN creation, security setting, QoS profile, advanced, and everything. So there is this 2.9. Okay. So you need to, if you do these 2 labs, okay, I think you already covered that one. Okay, cover both of them. But of course, when you do the configuration, you need to know about the fundamental theory. Okay. Okay, compare the Cisco wireless accessors and AP modes. Okay, have been given to you. Okay, apalagi yang lagi ada. For wireless, I think that's all for the wireless. This one. Describe the wireless security protocol. Okay, configuring WLAN using W2PSK using UI. Already done. Okay, already done this one. Okay, can you see the screen? Saya cakap macam
Yes,
hari itu.
very good.
Kita semalam sudah cakap banyak, tiba-tiba screen lah share. Okay, so that's all about the wireless. The wireless describe WPA, WPA2, 3. Okay. This one for security. Okay, but you already know about notification, authorizations. Okay. Yes, I think. So in here that we don't have any wireless. We have wireless here. Automation we don't have also. So number 5, okay, topic number 5, 5.9, 5.10 is wireless. And then this one, about this one, connectivity, we don't have it. So doesn't have. And then 2.8, 2.8, 2.7, 2.6, 2.8, 2.7, 2.9. Okay, it's also the most important things. And also 1. Here we have 1.1e WLC, 1.1d access point. Okay, and then we have in here another thing is in this one 1.11 describe wireless LAN connections. So this one related to the wireless LAN. And then please try to open the Dr. Cheryl's files that's given to you. So try to find all the questions related to wireless LAN. Okay. That's all for today. Thank you very much. Okay. So have a nice day. Assalamualaikum warahmatullahi wabarakatuh. Don't forget to sign the attendance, please.
How about this afternoon?
Oh, we don't have this afternoon. Okay.
Okay, thank you, sir.
You're welcome. Okay. Thank you.
Okay, sir.